Smart Dynamic Roadways with Integrated Wireless Charging and Vehicle to Grid Systems by Dylan Brady, Conor Halbert, Darnika and Goku. Introduction. Picture a future whereby electrical vehicles never had to stop while charging, but also the roads itself power the driver's journey. Looking at a smart dynamic roadway integration, wireless charging and vehicle to grid system, this picture can become reality if implemented effectively. With that said, these creative infrastructures and charging coils under the road surface, thus allowing the vehicle to recharge while driving or even parking. As a group, we believe that's a game changer for lowering anxiety for users, but also enabling smaller and more efficient batteries, thus making a path for adoption of electric vehicles. But the story doesn't finish there. Vehicles to grid systems improve this idea by changing electrical vehicles into mobile energy assets. With that said, looking at biodirectional energy flows, these vehicles can contain more power when there is a low demand period and transfer it back into the grid, or even when it is required, thus making it a stable energy supply network, but also lowering overall costs. This system is joint mobility and energy, making a much smarter and a greener environment, whereby transportation becomes the enemy when fighting the crisis of climate change, which is a big problem in today's world. In this presentation constructed by the group, we will explore all these technologies and the systems that are shaping our future. Problem definition. Firstly, inconvenient charging and range anxiety in relation to the electrical vehicle users about lack of charging facilities and poor distribution, but also long waiting times. This overall makes the user experience frustrating and unreliable. Also, electrical demands are growing for electrical vehicles, thus risk of challenging the grid and causing poor energy management, especially during peak times. With that, there is a slow electrical vehicle adoption, which is a huge challenge, which can delay progress in relation to the sustainability of transport. There's huge economic costs on charging infrastructure, putting pressure on all the stakeholders involved in the system. Conventional solution barriers are static charging networks are too dominant but are inconvenient, while the vehicle to grid solutions just lack scalability and user trust. Finally, smart dynamic roadways have a huge opportunity in achieving sustainability growth by strengthening the grid's resilience and convenience, but also boosting the user's confidence in the system at hand. Stakeholder map and persona. Personal information. Dylan Brady, who is age 22, is a student in NYG and lives on campus with a low budget, making €12 an hour at a part-time job. Transport and tech use. He also owns an e-bike and sometimes uses public transport, but is highly skilled with tech tools and app goals. Wants a cost-effective but also an eco-friendly transport option, which is in time commuting and affordable technology while supporting sustainability in his studies. Challenges. There is a limited e-bike and electrical vehicle charging station locally and unreliable public transport causing him delays. With that, the financial challenge, limiting options and advancements in electric vehicle systems. User needs. Affordable and reliable electrical vehicle solutions, thus allowing him to access a smart travelling planning app for efficient moving and consistent transport resources across the campus in Galway. Wider vision. He wishes to put forward his ideas to smart roadway creativities to allow better and more sustainable urban transport. Future hopes. Affordable electrical car options for better transportation, making it flexible and sustainable for users. On the right, you can see a stakeholder map. Here you have the indirect stakeholders, which are the environmental organizations and the public, general public. In the direct, then we have the technical or technology developers and suppliers and the government. And in the core, you have the electrical vehicle owners and users and energy providers and the grid operators.
Level of innovation. The proposed solution for smart dynamic roadways integrates new technologies with existing infrastructure and roadworks. Our new solution stands out as it addresses challenges in the electric vehicle revolution with new inventive solutions to the current problems faced. The key selling points of this solution are dynamic wireless charging. Wireless charging in motion eliminates range anxiety and the need to stop and recharge. This addresses the limited range on electric vehicles while also completely eliminating downtime on driving. Vehicle to grid integration. This enables vehicles to supply energy to the grid while not in use. This dual functionality will allow vehicles to both act as a form of transport but also as an energy source for other vehicles when not in use. Scalability and future potential. Our idea can be implemented to existing roadways, which can lead to widespread adoption of electric vehicles. Why our solution stands out. Our solution resolves major issues with electric vehicle transportation that are it eliminates the range limitations while with wireless charging, and it provides seamless integration with renewable energy resources.
Hi, this is Dharnika Govindarajan Revati. I'm going to explain briefly about the detailed solution. So, our project is Smart Dynamic Roadways with integrated wireless charging and vehicle grid system. So, basically, we are going to integrate two ideas, like we are going to integrate the dynamic roadways with integrated wireless charging technology with the V2G system. So one of the idea is using the resonant inductive coupling. It is that the roadways will be fitted with the embedded coils. The resonant inductive coupling, how will it work? Like it will transfer the energy between these embedded coils. So whenever the vehicles are moving on the lanes will be a charging lanes. So whenever the vehicles are moving on the lanes, that will be designed in such a way that the energy points present in the lanes will transfer the power to all the vehicles. And another is charging zone. So the charging zones will be present in urban areas and the highways. And also why it is present in the urban areas is to ensure that the vehicles remain charged, and located in the highways is because to ensure the long stretch for the continuous charging. And this is the energy is incorporated with the help of renewable source of energy, because Ireland is well known for usage of renewable source of energy. And we are going to integrate the V2G system by bidirectional inverter method. That is, two types of stations will be there: parking station and the charging station. The parking station is like static and the charging station is like dynamic. So the basic flow chart is like, we are going to start when the vehicle is there in the charging line. The battery will be checked whether it is charging or discharging. If that is going to charge, then there will be a dynamic charging, that is, it will be done in the charging station, and then energy flow will be managed and vehicle exits the charging lane. If it is discharging, that is, it will go to the V2G decision, and it will go to the vehicle 2G activation, and then user incentives credits will be given, that will be discussed in the upcoming slides, and then the process will repeat. Coming to impacts and benefits, so the benefits is like, the first benefits is frequent stops will be removed, so that now they can charge whenever they want while driving, and can also travel long distances. There will be no problem of battery issues, and this will help more efficiently in heavy traffic situations. And the next benefit is like reduced range anxiety. It is like range anxiety will be reduced because we are integrating the charging lanes with the roads, and the electric vehicle riders will feel confident because they can now confidently depend on the dynamic charging system. And the major benefit is like the waiting times will be eliminated, electric vehicle usage is also increased, renewable source of energy is used so that there will be no pollution effects, and the long time wait is also reduced in the city traffics. And the cost will also be saved, like incentives will be given, and the electric vehicle itself will act as energy storage units. And the impacts are like, mainly the impact is air quality will be improved. Before and all, dangerous, like currently dangerous pollutants will be released, so that it will be reduced because of the usage of solar power with our idea, so that air quality will be improved. And also health outcomes will be given as a best results, especially for the people who are living in the busy areas. And there will be an increase in the demand for electric vehicle adoption by approximately 30%. And this will improve the traffic flows, it will reduce the traffic delays, cut down the waiting time, and also that will be easy for congestion around the charging stations.
Hi, I am Gopalakannan Damodaran. I am going with the implementation plan, that is month 1 to 6 is the phase 1, market and technology research, planning, feasibility studies for evaluating cost and benefits, stakeholders engagement and defining the key metrics. And for the month 7th to 12th, the phase 2 will be identifying and selecting site, designing the infrastructure, developing infrastructure and testing the functionality of wireless charging and V2G system, public awareness campaigns. For the month 13 to 24, that is the phase 3, expanding the deployment of wireless charging lanes, integrating the renewable energy sources, developing smart energy management systems, and collaboration with e-vehicle manufacturers, that is stakeholders, and monitoring the performance and optimizing, and finalizing the phase 4, that is month 25 to 36, expanding the system to additional urban areas and cities, integrating with the smart city systems, launching dynamic pricing and energy credit incentives, continuously evaluating their performance. And coming to the next steps, our implementations will be of a short-term basis and long-term basis. Coming to the short-term basis, test the dynamic wireless charging and V2G system in the controlled setting, not in the bigger manner. And next feasibility studies and the pilot product projects. Next step to the work in short term. This steps like proceeding to work with the higher level authorities about this infrastructure in implementing higher level, and also with the energy suppliers. And also development can be made with the help of AI improvements, and also can refine the charging technology. And coming to the long term implementations, extending this infrastructure design from basic project level to larger areas, that is the highways, cities, busy areas, and etc. From this large amount of e-vehicles and technology, for this large amount of e-vehicles and technology is required, and that would be considered as a long-term development and a successful development also. For this, the approval from local government authorities and regulatory agencies is mandatory. The support we need to move this idea further is the government support is mandatory to implement this and to advance this concept and to improvise more both in short term and long term. Support government is necessary for funding and the regulatory pathways too.
Our conclusions for our project, Smart Dynamic Roadways. Smart Dynamic Roadways address the issues faced in the revolution of electric vehicles across the world. By combining wireless charging with vehicle-to-grid technology, this will create an electric vehicle future that is more efficient and sustainable for all. Our solution lowers carbon emissions, combines the use of renewable energy with electric vehicle transportation, and will increase electric vehicle enactment across the globe. The future of our proposed solution is a transportation system driven by smart dynamic roadways that is cleaner, smarter, and more effective for electric vehicles.